Hello there. So today I'm going to talk about how to put a PC set or pitch class set into normal form and then prime form. In the beginning of the 20th century, composers started to completely abandon tonal music and go totally atonal, meaning there's no tone center, there's no key, the piece is not in a key. So before, when we've analyzed music, we've used Roman numerals and secondary dominant Roman numerals and things like that. The 1 chord goes to the 4 chord, goes to the 5 chord to analyze music. Well, now that we're in totally atonal music, that won't work. So what does work to help us analyze this music is to look at some of the pitches used, put them into pitch class sets, and then analyze those pitch class sets. So that's what we're going to do today. We're going to take a pitch class set, take a few, put that into what's called normal form, and then put that into, find the prime form of that as well. And I'll describe those as we go along. So let's get started. Okay, so let's take a look at the example in the tonal harmony textbook, Schoenberg, 3 piano pieces, opus 11, number 1. The piece starts with the notes B, G sharp, and G. So B, G sharp, and G. And we're going to consider that a pitch class set. Now, to find the normal form of this is to find the most compact version of these 3 notes. Okay, so think of it as like in tonal harmony when we would be looking at a big chord, let's say like this. If we had this big chord, we'd want to stack it up in thirds to analyze it easier. So we would bring the F sharp down here, A would stay, C would come down here, and then we'd say, okay, this is a D7 chord. Same kind of way here, we're putting this in a more compact version like this to analyze it, and that is the normal form, the most compact version of these 3 notes. So how do you do that? Well, you'll write it out in 3 ways. So first, we're going to we'll start on B. Just take any one of these to start on. We're going to have 3 versions of this. If you have 3 notes in your PC set, you're going to have 3 different versions. If you have 4 notes in your PC set, you're going to have 4 different versions. If you have 5 notes in your PC set, you're going to have 5 different versions, and so on. Because each version will start with each of the notes of the PC set. Now we go up to the next closest note, because again, we're looking at the most compact version, so we're not going to go from B and then go to G sharp and then a G above that, because we're already not in a compact version. So out of these 2 notes left, what's the next highest note above B? It would be the G. So we go up, and then the next highest note above that is our last one, G sharp. Okay, so that's one of our versions. Now, pick another note to start on. Let's start on the G sharp. Okay, and go to the next note up from that. So what's the next note up from that, B or G? Well, G is a half step lower. The next G would be all the way up here. So B would be the next one up from that. So we're on B, and then our last note going up is G. And then our final version starting on the G. Next note up from G would obviously be the G sharp, just a half step higher. And then B. Okay, so looking at these 3 visually, this one's a bit easier to see the most compact version. Sometimes they're not so easy to see. You definitely want to count out the half steps or check the intervals just to double check. So in atonal music, we don't typically use minor thirds, major sevenths. We're good at that by now, but you typically count in half steps. So there's a few ways you can do that. You can count all the half steps. If you're familiar with the keyboard, it's easy to count half steps on a keyboard or whatever your instrument might be. Or you could think of it as the big interval and then transfer that to half steps. So this first one here, B to G sharp, how many half steps would that be? Well, I know it's a major 6th. Translate that to half steps. It's 9 half steps. Okay? Then G sharp to G, one half step less than an octave. An octave is 12 half steps. So that's 11 half steps. And G to B is a major third. How many half steps in a major third? 4. Okay, so then this confirmed what we already knew just visually, that this was the most compact version. But again, I would definitely recommend just doing this for practice every time, because you might have ones that are a lot closer calls that you can't visually just tell right away. You'll need to count the half steps. Okay, so this is the winner here for the most compact version. And so of this PC set, this is in fact the normal form. G, G sharp, B. Here's another example I wanted to look at. I have already written it out. This is my PC set, B flat A, D flat F. I've written out all the combinations. Remember, since there's 4 notes, we're going to have 4 combinations in compact form to try to find the most compact version, which is the normal form. And I've already analyzed the outer interval, and we're going from the first note to the last note, and looking at that interval in half steps. These numbers are in half steps, 8 half steps. And look what we have here. We have a tie for the lowest amount of half steps. This one is 8 half steps, and this one is 8 half steps. So which one of these is the normal form? Well, for the tiebreaker, we just go down to the from the first note to the second to last note, and we check that interval. So this note to this note, and this note to this note, and whichever one has the smaller interval there is the normal form to break the tie between these two. Now, if those two are the same, then we do it again, and we go from the last note to that note. But let's check this one first. So we have F to B flat, a perfect fourth, which is 5 half steps, and then A to D flat, a diminished fourth, which is 4 half steps. So this one is smaller. This one wins the tiebreaker, and this right here is the normal form of that one. So that's what you do if you have a tie. So now we're going to go over how to find the prime form of this PC set. So the prime form is what we're going to use to name a set class using integers. So the first thing we do is we grab our normal form again, which we've already figured out from this original PC set was G, G sharp, B. That was our normal form. Now we're going to take these notes and we're going to translate them into numbers. So to do that, we use the C is 0 system. So C is 0, C sharp or D flat is 1, D is 2, and so on, all the way up till we hit B is 11. And then if we would reset back at C, we just go back to 0. All right, so again, just counting half steps up, just remember C is 0, and then count up half steps. So G would be 7. G sharp, a half step above that, would have to be 8. And then our B is 11. Okay, so 7, 8, 11 is our normal form in numbers. Now we want to transpose these numbers to where we start on 0. Okay, so let's do that here. So we want to start on 0. So what do we have to do to G or 7 to get to 0? Well, we just subtract 7. So we start on, that's a 0. And then do the same thing to each one. And remember, you could have a 4-note PC set, a 5-note PC set, all the rules apply. So 8 minus 7 is 1, and then 11 minus 7 is 4. Okay, so 0, 1, 4 is one of our possible prime forms. And it's typically written like that with no commas in between 0, 1, 4. Now we have to take one more step, which is a little tedious, but we have to take the inverse of our normal form and then find its normal form and then go through the same process. Okay, so what we're first going to do is we're going to take our 7, 8, 11 and we're going to invert it. So to invert the 7, 8, or 11, we have to say what number 7 plus what equals 12? Kind of like when we do inversions of intervals, like a minor third, the inverse is a major sixth because we say 3 plus what equals 9. Well, now we're thinking in a 12 system. So 7 plus what equals 12 is 5. 8 plus what equals 12 is 4. And then 11 plus what equals 12 is 1. Okay, so this is our inverted set. Now this is not usually going to be already in normal form. So we have to go through the whole normal form process for this inversion, okay? So what you should do first is translate all of these numbers back into notes, okay? So what's 5 in our 12-note system? Here, we can finish writing this out now, if that helps. D sharp or E flat would be 3. 4 would be E. 5 would be F. 6 would be F sharp or G flat. 7 would be G. 8 would be G sharp or A flat. 9 would be A. And 10 would be A sharp or B flat. There. Now we've got everything written down. Now we just go 5, and we have an F. And then 4 is an E. And then 1 is we'll call it a C sharp. All right, so now we take these 3 notes as a PC set and figure out its normal form, just like we did earlier when we looked at these 3 notes and figured out the normal form. Okay? So there will be 3 ways. And again, we just start on each note. So we start on F. We're going to just pick doesn't matter which one you start with. You could start with any of them. You're going to get the same 3 answers. So F, and then the next one of these notes up from F. So that would be the C sharp, and then the E. And now starting on E, what note's the first one above E? Is it F or C sharp? Well, the F's right there. Then the C sharp. And then starting on C sharp. The next note up from C sharp, is it F or E? It's going to be E, and then it's going to be F. Okay, so then we see which one is the most compact. This one also is somewhat obvious, but we can count the half steps for practice. So F to E, how many half steps? Major 7th equals 11 half steps. E to C sharp, how many half steps? I know it's a major 6th right off the bat, but I got to think about the half steps for a second and say, oh yes, it's 9 half steps. And then C sharp to F is kind of a strange one because it's a diminished 4th and it's 4 half steps. C sharp to F. So just as we suspected, this one has the least amount of half steps. So this is our normal form. So I'm going to write it over here, C sharp, E, F. Okay, now that we have our normal form, now we can repeat the steps we just did for prime form. So remember up here, we had our normal form of this and we converted it to numbers. Let's do that. So C sharp is 1, E is 4, and F is 5. And the more of these that you do, the quicker you'll get on transferring the notes to numbers and numbers to notes and all of that. Okay, then what do we do after this? We translated this to where the first note started with 0. So I'm going to just back up and do it over here. 0, if we make 1 a 0, then we transpose everything by a rate of 1. So subtract 1 from 4, we get 3. Subtract 1 from 5, we get 4. So that's our other possible prime form. Then that leaves us these 2 options, and from there you pick which one is the most compact to the left. So which one's tighter to the left? So this is just a half step here. This is 3 half steps. So this one is more compact to the left. This one is the prime form. Our prime form of this PC set is 0, 1, 4. And that helps us classify it and reference it to other PC sets that we explore and helps us name this as a 0, 1, 4 PC set, just like we name chords as as a 1 chord and a 5/5 chord. Same thing here with atonal music. We use prime forms of PC sets to name it as a 0-1-4 PC set. Thanks for watching this video on normal form and prime form of PC sets, pitch class sets in atonal music theory. Please explore this a little more. Try this out on your own. Listen to the music and analyze the music of composers like Hindemith, Schoenberg, Babbitt, to name a few. And I think you'll see the point in all of this. A lot of what I talked about today comes from the music theory textbook Tonal Harmony by Koska Payne, if you want to look through that for more reference.